Hi, this is Hongjin Yu, and I will be demonstrating my directed focus study, mesh generation with shape grammars. So what is a shape grammar? Shape grammars are basically L systems. So this is Wikipedia for reference. Uh, a shape grammar is basically an L system where the node corresponds to a 3D geometric object. So what is an L system then? An L system is pretty simple. So let's say you have two variables A and B, and you have two rules. A turns into AB, B turns into A. And so the first iteration, if we start with an A, the second iteration, A will turn to AB because of this rule. And the third iteration, A will still turn to AB, and B will turn into A. And you can see how this will expand. And so it's a very simple, straightforward system, but it is also very powerful. Um, so what would that look like in my engine? So let's see. So we start off with nothing but the root node, and that is generating the International Space Station. There's a reference. And on this side, you can see the tree view. So you can see exactly the rules and how are they spawning. So the root spawns the main module, and then which is this part. And let's see, to demonstrate, I will just spawn the main module. After that, you'll spawn the wings, and it's starting to spawn these retractable solar panels, and these are spawning the solar panel rods, and you have the full solar panels, and after 10 iterations, everything is generated. So you'll also notice that every single time the generation is slightly different. That is because these parameters are being randomized, but I can control them directly. So now the contractible solar panels are always at the same angle. The sun angle, set that to a value. And so you can see how this system is very easy to use. I don't need to recompile to make the system work. It's using Python under the hood. The scripting is done in Python, and Python generates this tree. The meshes, all the vertices, all of that heavy lifting is done on the C++ side, because if it was done in Python, it would be very slow. So to show off some other things, it's easy to generate these tree-like structures through recursion, and I'm also using a random value for the parameters. And here is another one. I'm attempting to generate a space station-like structure. So you will notice these solar panels, they're the exact same solar panels that were on the ISS. So basically, if you make a node, you can plug and play it anywhere. It's kind of like Legos. And this gives this whole system a lot of flexibility, a lot of room to play with, a lot of freedom. And if you want to dig into it, you can also see the tree structure over here, and you can see at certain nodes there are solar panes. And basically, each one of these function definitions in Python corresponds to a node in the L system. So I would also like to show some of the Python and C++ binding. So I exposed not a lot of classes. I exposed my game object Python, my vector3, my matrix, transform, and that's it. And I expose all of the functions except for the functions that used other classes. For example, if they used RGB, which is one of my classes, and I did not expose that, so I would also not expose that function. So all of these functions are self-contained within these 4 classes. And Python can call into, it can create these classes, and I'm using PyBind 11 to bind these functions. It's pretty easy to use. One thing that needs to be taken into consideration is Python does memory management while it does automatic garbage collection and reference counting, while C++ does not. And so when you're passing an object from C++ to Python, Python really doesn't really know, okay, what do I do with this object? Is it mine? Can I garbage collect it or not? And so sometimes you need to tell it, okay, so this is telling return value policy reference internal. And what this means is don't garbage collect this Python. The lifetime of this object is managed in C++, and also it's dependent on a parent object. So for example, get world to parent, this will return a matrix, and that matrix is stored in cache on the transform. So that belongs to the transform. So this is basically saying, Python, please don't delete this, because I know I'm managing that. Binding the functions is pretty straightforward. This is just a pointer to that function, and this is the name in Python. And PyBind will automatically infer the parameters through templates. It's also very easy to bind operator overloads, and this purple color means that this expands into a macro, but this is all pretty magical. You can also expose, for example, vector3, I want to expose the x, y, and z members, and that's also pretty easy. So if you notice, every time I hit Control S, I don't need to click over here. I'm just hitting Control S. Every time I save, this thing will regenerate. And you say, okay, what if the program crashes? So this is a syntax error. I save, and the program does not crash. It will output the traceback to help designers find the error, and it outputs the line number, everything. So it makes debugging easy, and I don't need to restart the program. Just need to delete that, and everything is good. So some of the things that I planned and did not get done was a split function. So that basically would split geometric objects. Right now I only have cubes, but let's say you have a circle, if you had a sphere and you split it, it would become 2 half spheres. Decompose is one I didn't get to. This would basically, let's say, if you had a cube, it would decompose it into each of the faces, and each face would be a mesh that you could work on. I was planning more primitives, so currently I only have cubes, but I was planning spheres, capsules, and other shapes. So things I didn't plan, but I got into the game. Safe reload on safe, so I'm checking in Python, I'm doing a try catch. So if there is an error, the program will not crash. This tree graph is really nice for debugging. And I bound a lot more functions than I expected, because binding them was really easy. So some of the takeaways: scripting is really fun. It's really nice to see your code turn into something visual with just a click of the button. debug tools pay dividends. So this tree structure, um, this really paid off because it helped with debugging. I also have so the Python side and the C++ side are completely um, decoupled. They're completely decoupled. So I can, for instance, I can run the Python side without generating meshes, but it will still generate the same shape tree. And this was also very helpful for debugging. The iteration time is really fast. I can change variables, save it, and it will automatically update. And not only that, I can also change functions on the fly. So that's opposed to data-driven. If you just have an XML, you can only change the data, but if you want to change a function, you'll have to go back to C++. I think it's a really nice tool, and I plan on reusing this in the future. And that concludes it. Thank you.